Today we're going to talk about importing a CAD model, manipulating the CAD origin, and performing an initial alignment in CMM-Manager. We'll do 3 examples: importing a simple CAD model, first with the origin on the corner of the part and performing an alignment immediately. Second, with the alignment, the CAD origin somewhere off of the part. For instance, in an in-car coordinate system, we'll look at using some tools to move the origin back to the corner or somewhere local to the part and perform an alignment. And then finally, an example where the CAD origin is somewhere off of the part, again in some sort of in-car coordinate system, and look at how to perform an alignment using a best fit alignment followed by an RPS alignment, so that we can actually inspect this part in this assembly or in-car type coordinate system. So we'll start by bringing in a CAD model. So we can browse to the CAD model that we'd like to use. So if we zoom out, we see that the CAD model is brought into the machine volume at the machine home. And looking at the coordinate system of this CAD model, we see conveniently the origin is on the top front left-hand corner of this part. So that lends itself well to simply doing some sort of plane line point alignment. So in CMM-Manager we have a number of what we call canned alignments. In this case we'll choose 3-2-1 alignment. So the software is going to ask me now, using the joystick, to simply measure a plane, a line, and a point. So with these canned alignments, we'll get some sort of preview of the coordinate system that we're about to create. Graphically, we see this yellow flashing preview. Of course, we have some opportunity to change that orientation, with the idea being that the orientation of the measured alignment needs to match the orientation of our CAD alignment or CAD reference frame. So when we click OK, that automatically synchronizes the CAD model to the appropriate location, as well as finalizes our measured alignment. So at this point in the project, we're able to start picking some features from the CAD model for measurement, and the software, of course, knowing where the CAD model is located in 3D space, is able to go and inspect these features that we've picked. So let's start a new project. So we're starting our project in teach mode so that we're teaching a program. We'll come back to this Import-Export tab where we're able to import our CAD model. This time we'll select from a list of recently used CAD models. So I have the same part, this time again with the origin being out in space somewhere. So in the Import-Export tab, there's a number of tools that allow me to pick CAD features to relocate the CAD origin. So using tools with terms that you're familiar with already, level, align, set origin, you can simply pick features directly from the CAD model to reset the origin. So in 3 steps, we've been able to resituate the origin back to the corner of the part in this case. Maybe in this example, instead we'll pick some other feature on the part for our origin. So again, keeping in mind the location and orientation of the CAD reference frame or the CAD alignment, we'll come back to our Measured Alignment tab. Again, we'll use one of these simple canned alignment procedures, maybe using the plane line circle. So again, if we just follow the prompts that the software provides, we can measure a plane, a line, and finally a circle. And again, taking note the orientation of the CAD reference frame. We make sure that our measured reference frame matches. So when we click OK, this automatically synchronizes the CAD model. And again, we're in a position now where we could start picking features. And continuing with the measurement portion of our program. So one last example. Again, we'll start a new project. Make sure that we're starting in teach mode. We'll actually bring in the same CAD model. This time we're not going to use the alignment tools here to move the CAD origin. We're actually going to leave the CAD origin in this location out in 3D space. So the absolute easiest way to negotiate some sort of alignment like this time we'll do a manual alignment, and we'll follow up that manual alignment with a DCC alignment. So the manual alignment that we'll use is a CAD alignment. This is a best fit alignment, and essentially allows me to pick any number of points on a CAD model. So the part that we're dealing with today is some prismatic part. Essentially, we're picking points in the fashion of a 3-2-1 or plane line point type of alignment. For sake of illustration, I picked one point not directly on that top surface. So the second step of this alignment is to actually perform the measurement. So the software is going to prompt me to measure each of these 7 points. So again, just using my joystick, I'm going to try to measure the points as indicated on the graphic here. So after using this CAD alignment, we'll get some reporting information here telling me about the average deviation of the alignment. If we're happy with that, we'll click Confirm. So now we can see that the CAD model is automatically, again, synchronized to the actual location of the part on my CMM. And as I mentioned, we'll follow this alignment up with the DCC alignment. So we're actually going to measure some features, and in this case, we'll set up an RPS alignment. So I'm going to set up 4 measured points. One of them at a unique height, again, to show that this could be used on some non-prismatic part. So we'll set up 4 measured points. We'll measure the center circle. We'll assume that this is our secondary datum. And then finally, we'll measure another one of these circles, assuming that that's our tertiary datum. So we could actually perform the measurements of these features. Function inside of CMM-Manager, Simulate Verify, accessible from your quick access toolbar. Just by putting my cursor at my program database at the desired start point, I can select the Verify option and then go. So this is a good way to test out some measured features that you've created in a program without verifying each feature individually. You can run a whole block of measured features. So our verification is complete. We have real measured data for each of these 6 features. We'll go to the Alignment tab, choose RPS Alignment. So our 4 points on the top of the part, acting as our primary datum, for controlling the z-axis. So as I'm checking z-axis on each one of these, you see the nominal values for each one of those points. And of course the point that was down in the bottom of the counter bore has some unique z-axis nominal value. Our secondary feature is contributing to two locks or two constraints of the alignment, x and y axis. And then finally, circle 2 we'll use to constrain the y-axis. So when we're using an RPS alignment, you can either manually specify plane and line offsets, or you could simply click the preview button and the software will actually provide a list of all of the possible solutions for this alignment. So we, of course, pick the alignment that displays a preview that's coincident to the CAD origin. We click OK, and then we click OK again. So now we've completed an alignment where we've leveled to our 4 datum target points on the top, set an origin to the larger of the 2 holes, and then performed an offset alignment through the second hole, all by using the RPS alignment. So once again, we're at a point in our program where we can simply start picking some features from the CAD model for measurement. So before we wrap up today, I am using some settings in the software that are maybe not set up by default in your installation of CMM-Manager. So if we go to the Display tab, by default, when you've loaded a CAD model, of course the CAD model will be shown. Optionally, I'm also showing the CAD coordinate system or the CAD origin. So by clicking this button, this Show Hide, it's actually showing the CAD origin. For me, that's a nice reference to visually see my CAD origin versus my part reference frame origin. Initially in your program, these two should be coincident. Of course, as you're programming, you may at some point in your program set an origin to some other feature in your program, so you're able to have a new part coordinate system while you're maintaining your CAD coordinate system. The other settings that you should be interested in, if we click on the Start Pearl, Preferences, there's some preferences to do with reference frames or alignments. So by default in CMM-Manager, the Keep Temporarily Created features and Auto Sync upon first complete reference frame will not be checked. By checking both of these checkboxes, first of all, when you're using these canned alignments, your measured features will be retained in the feature database. And then secondly, the Auto Sync CAD option will automatically perform the CAD synchronization that we saw in all three examples today. If this option is not checked, you would need to manually perform the Sync CAD operation. So that finalizes the tutorial for today. I look forward to seeing some additional tutorials in these new YouTube video formats as opposed to the older static PDF tutorials that we've provided in the past. Thank you very much.